Hi viewers, very good afternoon. This is Dr. Gunamani Jana, and you are welcome to our video lectures on object-oriented analysis and design using Unified Modeling Language. In this video, we are going for the details of these various uh, diagrams using the UML. The one of the very important diagrams what we are using is the class diagram. Even if we are having 9 number of diagrams there, as I already explained to you, out of that, one of the important diagram is the class diagram. Okay, so we are coming to that now. These are the, I think these are things already covered in my previous things, and we are going for this. The building block in the unified modeling languages, there are the three fundamental building blocks or whatever. So the building blocks for the UML, one is the things, second one is the relationships, third one is the diagrams. Things is again further divided into four type. One is the structural things, second one is the behavioral things, third one is the grouping things, and fourth one is the notational things. Is it okay? So building blocks are three. One is the things, relationships, and diagrams. And things further divided into four: structural things, behavioral things, grouping things, and annotational things. The structural things, this is one of the important in this is the class diagram, the component diagram. These are the things coming under the structural things. So if you see that scenario, the documentations, the nouns in a sentence, whatever the sentences we are using, they will be treated as the things for the structural things, and they are mostly static part of a model, and they are representing elements that are either conceptual or physical. All things we can see, all the class diagrams what you are using it here. Suppose it is a window, we are taking a class diagram. The class diagram, the notation, the name is starting first with a capital letter W, and all the attributes in the middle compartments like origin, size, etc., and all the operations in the bottom compartment, open, close, move, display, they are followed with the open parenthesis and also closing parenthesis. So these are the things, and a class can also implement one or more interfaces. It's okay, and it is rendered by a rectangle. These things we know. Then second is the interface. As I told you that interface, it is a collection of operations that already we discussed in the class and all things. So we write uh, any interface start with the capital letter I. See, I is your I spelling. Okay, spelling check we are going or all things like that. So then coming to the collaboration. Collaboration, it is a dashed line, and it is just like an ellipse or dashed ellipse, I can say ellipse. So collaboration defines the an interaction and is a society of roles and other elements that work together. Society of roles and other elements that work together to provide some cooperative behavior that's bigger than the sum of all the elements. Okay, this is the things we use it collaboration. Then we go for the use cases. Use cases is a description of a set of sequence of actions. That is the use cases. Place order, do this, do that, like that, all things. Use case is to structure the behavioral things. Okay, for the behavioral things, we are using these use cases in the model. And use case is realized by a collaboration. And graphically, use case is rendered just like an ellipse, solid line ellipse, right? Then active class, you can see, is just like a rectangular container, but the thickness of the wall is little more. You can see it there. Okay, an active class is just like a class, except that its object represent elements whose behavior is concurrent with other elements. When the behaviors are concurrent with other elements, then we say it is active class. Okay, so it will have the same thing, including the name, attribute, and operations. All will be same. Then coming to the components, this is the physical and replaceable part. So it can be a DLL file, it can be a Java file, it can be anything. You see the example, a rectangle is containing another two rectangle in the same side, left and right hand side. So this is the component, is a physical and replaceable part, right? Then coming to the deployment or the nodes, it is just like a cube or cuboid, whatever you see it here. So this is the physical elements that exist during the runtime. Okay, it is represented by a node or it is represented by a cuboid, right? So it is rendered using a cube. Then the seven elements like the classes, interfaces, collaboration, use case, active class, components, and nodes, basic structural things. We are talking about the structural things. Okay. In addition to that, we are having something like the actors, okay, signals, utilities. These are the things also there. Then coming, this is the structural things. Coming to the behavioral things. The behavioral things, these are the dynamic part of the UML diagram or UML model. They are of the verbs of a model. Behavioral things just like the verb of the model, display like that, print like that, all things are there. Okay. So first, and you can see it here. Uh, we provide in the form of some just messages. You see an arrow mark, a line with an arrow mark, and the verb is here display. This is the things it is coming the behavioral things. So we are having the state machines or the this depicts the different states of a object. So represented by you can, it is just like a rectangle, but the corners are tempered like this, right? So these are the state. And grouping things, it is just like a package and all things packets like that. Similar type of things, they're grouped together. So you see a small compartment, it is above another compartment interacted. So this is a package. This is general purpose mechanism for organizing elements into groups. Similar type of things. Okay, the structural or the behavioral things and even other grouping things may be placed in a package. Then coming to the annotational things, it is just like the explanatory part, just like the comments and everything you are giving, return copy yourself or like that. These are the comments you may apply to describe or illuminate and remark about any elements in a model. And there is one primary kind of annotational things called the note. We write some notes there. Okay, these are things. Example, you can see it here. And the rectangle, the corner is just bent. You see the corner of this part, it is just 90 here. They're cutting some portion, bent it like this. Then coming to the relationships in the UML, we are having various type of relationship in the UML diagram. The association, the dependency, the generalization, the realization. If you see the dependency here, it is a semantic relationship between two things. It's a semantic means it is having some meaning. Semantic relationship between two things in which a change to one thing may affect the semantic of the other things. If you are making the change to the thing in the left hand side, it will automatically change the meaning in the right hand side. Okay, these are the dependencies. So similarly, the association. Association, it is a structural relationship that describes the set of links. Okay, for example, employer and employee. Okay, so all the employee associated with an employer, because we cannot say somebody employer if employee is not there, and an employee cannot stand isolately. So I am employee. Who is your employer? We do not know. Who will paying money? No, not like that. Okay, so we say the employee is associated with the employer is the owner, employee the person who is working under them. So it can be 0 or 1, no employer or at least one employer, and there can be many employees. So these are the things it is associated. I can give you some examples. Suppose a wall and the window and doors. A window is associated with a wall. Door is associated with a wall. This type of things we can come for association. Generalization, you can see an arrow is there, one line is there, at the end one arrow is there. Not solid arrow, but an arrow is there. Generalization or specialization, generalization, whatever, these relationships in which objects of the specialized elements are substitutable for the objects or the things. So we can say the accounts is the generalized, and the savings bank account, current account, gold account, senior citizen account, loan account. These are the specializations. Okay, this in this area. Then is the realization. Realization is also a dashed line with an arrow on there at the end. So what the meaning of these things means? Wherein one classifier specifies a contract that another classifier guarantees to carry out. One classifier specifies a contract that another classifier guarantees to any carry out. So this is the things we the realizations. These are the some of the things. We take an example here. You see there are a number of no classes are there. School is a class, student is a class, department is a class, course is a class, instructor is a class. These are the things we see. So school is aggregate of students. School is also aggregate of department, and it is mandatory because you cannot consider a school without a department. Similarly, a student is associated with a course, or the student attends a course. Is clear? And a department referring a number of courses. So this is the association. Similarly, the relation between course and instructor. Instructor teaches a course. Course means the subject what he teaching. And coming to the department and instructor. So department has instructor. Department is a aggregation of number of instructor, and and the instructor is associated with the department. It's clear. This is the chairperson. These are things, and one is to one, one is to many. All things we can depict it here. So we are having 9 number of diagrams. Those diagrams are the class diagram, object diagram, use case diagram, sequence diagram, collaboration diagram, spreadsheet diagram, activity diagram, component diagram, and deployment diagram. We are going for the um, for modeling the basic things we require is the class diagram, object diagram, component diagram, and also the deployment diagram. It's clear. So the other 5 additional diagrams also we need for the dynamic part. Here the use case, the sequence, collaboration, state set, activity diagram. Okay, these are the dynamic, and these are the static type. Static type for what are they? Class, object, COCD, class, object, component, deployment. These are the static, and the dynamic is use case, sequence, collaboration, state chart, activity diagram. These are things, right? Now we give an example of this class diagram. See, a class is represented by or rendered by a rectangle here, and it is having 3 compartments. The top one is the name of the class. Suppose the name is shape. Name start with a capital letter, and the middle compartment it is a collection of number of attributes. Origin is one of the attribute. Similarly, the bottom compartment it carries a number of operations like move, so opening braces and closing braces, resize, display. Similarly, coming to another class, rectangle class. The rectangle is the name of the class. Attribute, say we don't have an attribute here. So operations add, grow, move is empty. So if it is a compound word more than one word, then it follow the camel notation. That means starting of every subsequent word it is a capital letter. So first is is, it is a lowercase I, but second word is starting with e must be capital letter. This is called the camel notation. Similarly, coming to the another class customer. For this customer, this is the name of the class, and these are the attributes: name, address, phone, birth date. Similarly, suppose we want to give the data type. Suppose wall is a class. In the wall class, we are having height. It is represented by float. Width by float. So height is equal to, say I say 3.15 meter. Width I say 4.5 meter. Thickness I say 0.25 meter. That means 25 centimeter. So is load bearing Boolean data type, and false. No, it is not a load bearing because it is a frame structure. It's clear. So like that we can go for that one. Another example of class diagram, I explain it here. Suppose I go for the same school, student, course, instructor, and department. So you can clearly understand the school is the name of the class, and when you come in the attribute, the data type for name, it is name, address is equal to string, then phone is equal to number, something like that. Dot student, remove, these are the operations, get students, get all students, add department, remove department, get all departments. So this school has at least one department, or it can have many. So one is to many. So it's the cardinality. So we said that. So this is the aggregation we are using it here. So a school can have at least one or more department, one or many. I am giving it here department, and here for the name I am putting the name. This is the data type, and this is the operations for that one. And coming to the student, it is another class. It has attribute like name and student ID. Name it will take name data type, and student ID takes number, right? So now if you see the relationship between the school and the student, so it is the aggregation, because school is the aggregation of number of students. If student is not there, no, we can call it as a school. Similarly, a course. Student is associated with a course. Course is associated with a student. That means student attends course. For the course, attribute name and course ID. Similarly, instructors are there. The instructor teaches a course. So there can be many courses. There can be at least one teacher or more, star, one is to star. So like that, a department is the aggregation of the instructor or the faculty, or instructor is associated with a department, or department associated with an instructor. So these are things. So coming here also, suppose you take one more class diagram, that is the company, the department, the office. Here the person is there. Here the it is the dependency. That means if the person is different, then contact information will be different. If the person is different, then personal record is also, tax ID will be different, employment history will be different, salary will be different, right? So then it is realized using these interfaces, I secure information. So these are the things, and here as company is a aggregation of this is part or whole. When company is the whole, department is the part. Okay, company is the whole, office is the part. Okay, these are things. Okay, so here the relation is has. School has department, so this is also aggregation. I am putting it here, right? So these are the things all about today's lecture. So in the next lecture, we will be going through what are the object diagram and how to write the object diagram and how to interpret all things. Thank you for watching this video. If you like this video, please do share with your friends, and I am appealing the students. So please attend all the classes regularly. Otherwise, there will be some problem, academic problem. Okay, below 65 percentage, they will face a problem for writing the exams. Thank you for watching once again. All the best.